In this video, we'll continue our learning on the reactivity of nucleophilic acyl substitution reactions for different acyl molecules. In the last video, we talked about amides, esters, and carboxylic acids, anhydrides, and acid chlorides, and that's what we'll continue talking about in these videos. To understand the trend in reactivity, which is covered in the previous video, it's helpful to think about the mechanism. So what are the steps that are occurring in these substitution reactions? Now we're just going to talk about a general mechanism. If acid or base are present, then the mechanism could look a little bit differently. But in general, all of these mechanisms contain the same few steps that we'll cover here. We'll also indicate and draw some transition states. So remember, transition states show bonds that are breaking and bonds that are forming for an individual mechanism step. So we're just writing out general mechanism here. We have, it is acyl group substitution. So we have an acyl group, and we'll say Y, the letter Y will represent the different groups that could be there. So if we are starting with an amide, then Y is an NR2 group. If we are starting with an ester or a carboxylic acid, then Y is an OR group. If we are starting with an anhydride, then Y is an O, carbon double bonded to oxygen, and then R group. So that would give us an anhydride. And then if we start with an acid chloride, then Y would be an acid chloride. I'm going to scooch these down to give us a little bit more room. So again, general mechanism scheme, and we'll talk more specifically in future videos. So if we are adding a nucleophile, this gets added to the carbonyl carbon, and we break the pi bond. Now, before we draw the product of this, let's draw the transition state. Again, we're showing bonds that are breaking and forming in this mechanism step. So we have the R group bond to the carbonyl carbon doesn't change. The Y group bond to the carbonyl carbon doesn't change. The single bond to oxygen does not change, but this double bond does, so we indicate that with a dotted line. And then the new bond forming between carbon and the nucleophile is a bond that is forming, so we represent that with a dotted line. We have in this step a partial negative charge on oxygen because in this first step, it has a neutral charge, and in the result of this step, it will be it will be negative. And then the opposite is true for the nucleophile. It starts off with a negative charge and it will become neutral. So it has a partial negative charge. So this is our transition state that brings us to the result of this step, where we have now a tetrahedral intermediate. So if we look back at the arrows that we drew on that first structure, we now have a single bond to oxygen. Oxygen gained a pair of electrons, so it has a negative charge. The bond to the Y group has now changed, and we have a new bond to the nucleophile, which is now neutral. So this first transition state that we drew in brackets, this is the transition state for the addition step. And then the structure that we drew, that's not the transition state, so this third structure is our tetrahedral intermediate. So we have in the addition step where the nucleophile adds, and then we have at some point in the mechanism an elimination step. In the elimination step, oxygen reforms a pi bond and the leaving group will leave. So we're reforming a pi bond and breaking a single bond. So the transition state here for the elimination step, R group to carbon isn't changing, the single bond between carbon and oxygen is not changing, but a double bond is forming, so we have a partial bond shown there. Oxygen will have a partial negative charge. The carbon to Y bond is breaking, so now that is a dotted line. And the carbon to the nucleophile bond is not changing, so that will remain the same. Now, when Y, the leaving group, leaves, it will gain a pair of electrons and gain a negative charge. So in the transition state, we indicate a partial negative charge there. Okay, so there's our transition state for the elimination step, and we get our final product where we have the R group still bonded to the carbonyl carbon, double bond to oxygen still present, and now we have the nucleophile bonded there. And then our leaving group, Y, with a pair of electrons from the bond. So the second transition state that we drew shows the elimination step. And then we have our final product, which is the result of the nucleophilic substitution reaction. We've substituted the Y group for the nucleophile that's being added. So we'll look at two different parts of this mechanism to understand the reactivity of these different molecules, and we'll do that in the next couple of videos.